just get started. Our first speaker is an invited speaker, Cruz, who's going to talk to us about Astropy.
So hi everybody. I've prepared some updates for the ADASS community. Typo on the first slide, that's fine. And I'm representing the project from the coordination committee. So I'm on the coordinating committee of the Astropy project. It's a 4-person committee at the moment, and I'll talk a little bit about governance changes later on the talk. And I'm also an associate professor at CUNY Hunter College. I'm based in New York. Before I get started, I also want to, give special thanks. So like most things in the Astropy project, it's a community collaborative effort. And a lot of the slides I'm going to be showing and graphics are from Adrian Price-Whelan and Brett Morris. And I want to thank Paleon Lim for giving me some helpful feedback on an early version of the slides. Feel free to tweet. There's nothing, I've got nothing private in the slides. Let's see. All right, so the Astropy project has a couple components. I think most people are used to thinking about the code ecosystem, but not only is there the core package, which is, import Astropy, but there's also the coordinated packages and the affiliated packages. And so I'm going to spend the first, third of the talk talking a little bit about the code ecosystem. I'm also going to talk about, another big component of the Astropy project, which a lot of people in the ADASS community may not be familiar with, there are education resources in the Learn Astropy project. And so we've been working both on developing content, so the content of tutorials and also workshop content and things like that. But we've also been developing infrastructure for supporting educational materials, and so that's something which might be of use to y'all if your projects are also developing educational content. That's something that we can work together on. Most importantly, really what I want to talk about today is our community of maintainers, developers, and contributors. And I'm going to throw a lot of information at you, but if I could spend the whole 20 minutes making this a recruitment talk and trying to figure out how to get more of y'all involved as contributors in the Astropy project, I would. So that's going to be the big takeaway. And we of course have a big community of users that have various forums and stuff. I'm not going to talk about that today. Unless people, want to ask questions or whatnot. I will be pausing at a couple places before I switch topics for questions. So if you have questions as they come up, please feel free to put them in the Q&A, and then Kathleen will moderate them when there's a good time. So in addition to the Astropy core, there's also coordinated packages. And so this is a system which we came up with, I think it's maybe been in the past 2 years. But so in addition to Astropy, there's AstroQuery, which I know many of y'all are familiar with. There's also sort of fundamental packages like regions, Astropy Heal Pix, and Reproject, and things that are used especially by a broad segment of the ground-based community, which are FOTUtils, CCDproc, and SpecUtils. So these packages are we see them as fundamental to the ecosystem of the Astropy project, and we intend to manage and support these packages with the same amount of detail and attention as we do Astropy core. So those are the coordinated packages. We also have a network of affiliated packages. So affiliated packages form an extra layer of the ecosystem that they're specialized, domain specific, but still interoperable packages with the rest of the ecosystem. So something like if I wanted to make a special analysis software for brown dwarf spectra, for example, and if I wanted to be sure that it uses SpecUtils and Astropy modeling and all of the API and interface standards in Astropy, I could develop that and apply for it to have an affiliated package status. We actually have a review process, and in the past year, we've actually formalized that review process a little bit. And so new packages that apply for affiliated package status are based on functionality. So, does it work? Does it do something useful to the astronomical community? Integration with the Astropy ecosystem. So that's also, minimizing duplication. So does it use things that are already built into Astropy core rather than reinventing the wheel? Documentation and testing. Honestly, the bars for documentation and testing are a little bit lower for affiliated packages, and so we use a lot of these review criteria to encourage best practices in development, and not necessarily to stop projects from having affiliated package status. Also, development status, and so development status is how well is it being maintained, and so that's an important one when packages get re-reviewed if they're currently under development. And Python 3 compatibility, which is something that is not as common these days. Throughout the talk, I have a whole bunch of URLs. I assume that at some point I'll be able to put these slides where everybody can see them. I'll definitely put them on SlideShare so that you'll have access to all the URLs. Okay. So a little bit more, so the popular package, so this is weekly PyPy downloads as a function of time. And then I've made the labels in approximate order in their download order. So you can see AstroQuery and PhotoUtils are the most frequently downloaded. AstroPlan is up there. SpecUtils, I expect SpecUtils to get more and more downloads. Glue, SynFote, CCDProc, Ginga, AstroGala, AstroML, and Stingray are among our most popular packages, just to give you a sense of their popularity. So here's a summary of everything that's been new in Astropy since January 2020. So there's actually been 2 releases since January 2020, version 4.0 and 4.1. I essentially randomly just chose things from the what's new. The point of this slide is to show you that the Astropy project is, really improving. There's active development going on, bug fixes are happening. The project continues to be healthy and being actively developed with new features being implemented. The Astropy core library, also just to show you some stats, and that we have the stats in particular, is very popular. So we have about 100 citations per month and growing, over 3,000 citations total, 16,000 dependent repositories and 879 dependent packages. So that's a lot. I also think it's helpful to note how useful it is that we did write a paper in the traditional, way. So actually, I'm not sure if it ended up in Astronomical Journal or Astrophysical Journal, but whatever, it's a easily citable paper that makes it easy for us to demonstrate its impact and usage in the field. For a lot of y'all, so things that are important. So the 4.0 series is the long-term release. So the plan is to support Astropy version 4.0 until 2021. Astropy 4.0 is the first long-term support release that only supports Python 3, so no Python 2 support. Something which we've been discussing very recently, which is to adopt adopt a schedule for upgrading the requirements for Python and NumPy. And so as of April 2021, we're going to bump to Python 3.7 and to NumPy 1.17. If you take a look at that Astropy APE, so that's an Astropy proposal for enhancement discussion, there's actually a table of dates that has our expected requirements. And so that's going to be changing. I think it's like maybe every 9 months or something like that. And I think, yeah. So at this point, I'd like to pause and see if there are any questions about the Astropy core functionality, affiliated packages, coordinated packages. Great. Azali asked a question. Any other? Well, I'll just take Azali's question. So Azali asks, what's the status of SpecReduce and how do you see it moving forward? Is there a roadmap? Is there funding? Azali, that's a great question. To foreshadow some slides, there is funding, but we don't, there also is a roadmap, I think in the APE, but the status of it moving forward is that it needs a lot of more, I think we basically need to reevaluate where we are with spec reduce. So since we did get funding in, so the Astropy project received a more grant in October of 2021. So that's jumping ahead to slides I have later. And so a lot of our focus in the past year has been just adjusting to the fact that we have funding and figuring out how to spend it and how to decide how to spend it, which is extremely non-trivial. And the funding in that there is money in that more grant for attention to the spectroscopic reduction capabilities, but that I think is going to be a focus in 2021.
On Discord, some people are asking, first, why change to 3.7 and why not 3.8?
Oh, that's not a question I can answer. Is that, I know that they were following the NumPy enhancement proposal, NEP 29. And so I'm not sure if that's just a community decision. Is that something, Adrian, that you can address? Or if anyone else has an answer?
Yeah, a more complete question was, what is the rationale for requiring Python 3.7? And is there essential functionality that Astropy depends on?
I mean, I don't have a concise answer, I guess, but you always have to choose, find the threshold of when to like improve our code base, because we can then rely on stuff that has been implemented in Python versus supporting older and older versions. And so we just decided to adopt the NumPy schedule. And yeah, I think that switching to 3.7 will allow us to remove a lot of legacy code, things that we had to implement that didn't exist in the language, that I can point you to specifics if you want to know, but that's the short answer.
And now, Kelle, do you want to continue with your talk? Are you okay with another question?
I like the questions.
Okay, so when and how did you decide that the project was mature enough to go for a classical journal publication?
Oh, that's a great question. So most recently, we actually worked on the second paper. So Astropy wrote the first paper, which I don't think I was a part of, relatively early in the process. But at this point, if we had staffing, I think to write a paper every year, we would. Adrian was actually on one of the leads, I think, on both of those papers. And so, Adrian, do you have any other thoughts on that?
I guess, yeah, we did it. Kelly's right. We wrote the first one in 2013, which was when Astropy was pretty young, and the most recent one was in 2018. We did it primarily as a way to just hack the credit system, and I've always been hoping that there would be other ways to do that would crop up. But since this does seem like the most the most efficient way, I guess, of getting people credit that they can take to their employer or whatever, I think Kelly's right. We should be writing them more frequently, but.
Yeah, I mean, and I would encourage folks to you know, like they say, right, write early and often, publish early and often. Especially now, I'm not familiar with MinRAS, or I'm familiar with the AAS journals the most, which is that they have a specific, you know, software editor now. You know, they're really encouraging. They want people to submit software papers, and there's also simultaneous publishing with the Journal of Open Source Software and Astronomical Journals at the same time. So AAS Journals is going to a lot of effort to welcome and support software papers. So I definitely highly recommend trying it. All right, good. Now I think I'm ready. Now I think I'm ready to move on. Great questions.
Yes, excellent.
All right, so because of time, I actually don't want to spend too much time talking about the Learn Astropy project, especially because the site is in the process of getting an overhaul. So we're expecting a full site overhaul in 2021. And as part of that overhaul, we're actually gonna introduce cross-platform searching. So if there's a tutorial that exists on another site, someone could search for it, like let's say Gaia had a whole suite of tutorials, we could include the Gaia tutorial site to be discoverable on the Learn AstroPy website. And so there's going to be potential for both for tutorials to be cross-listed, or if y'all have a bunch of tutorials but you don't have a home for them, we also will welcome contributed tutorials. So with the vision for the Learn AstroPy site is that it not just be a place for users to learn AstroPy, but to learn astronomical computing in Python, or eventually, we just see this as a home for a whole bunch of tutorials. Also, please check out the NB collection package. So this is actively under development, but it's gone through a couple different package names, and I think it has the potential to be super useful for the community for both testing and rendering Jupyter notebooks as HTML. And so that's all I'm going to say about the tutorials, because I want to get to my recruitment pitch, which is trying to get the sort of creative juices flowing. And a lot of what I'm going to say actually dovetails with a lot of the discussion. So I was looking at the birds of the feather discussion, the interoperability of users, managers, and developers. And so right now, it seems like in many organizations, it's not straightforward to see how the everyday developer would be able to contribute to AstroPy. And so I want to give some examples from other organizations about how this can happen, to try to shift the culture a little bit and to inspire managers, developers, future managers, to how we can modify the landscape to support more open source development. And so Chandra developer implemented a flexible way to add persistence attributes to an AstroPy table in their own application, and then later ported that feature to AstroPy. The Rubin Observatory has updated code for constructing color images, but also they contributed documentation updates, which is super useful. Added support for new units, which I expect was something that they needed for their own applications, and they did bug fixes. Similarly, developers of the Cherenkov telescope array had a great contribution to speed up coordinate transformations for large arrays of observation times. So that's something which I know a lot of people have pointed out, is that a lot of the AstroPy core was built for thinking about small scale implementations, and that development is needed to make it more efficient for big data type operations. But they also, just contributed bug fixes and enhancements. So just making things better for everyone. And of course, JWST developers at Space Telescope develop and maintain the WCS modeling subpackages and the PhotoUtils in regions coordinated package. And so one thing that so these are, organizations which are contributing to the project, but they're existing in an ecosystem where they see the AstroPy ecosystem as a part of their scientific stack and not as something separate. And so it might be difficult to sort of backport existing software to make contributing to AstroPy on task, in scope. But I think moving forward, thinking about new projects moving forward and how you can make an AstroPy AstroPy or a coordinated project or even an affiliated project a dependency and work in that ecosystem, then will make it easier for to justify and to make it in budget development within the community tools. A little bit about the contribution workflow. So if you don't just already have an idea because you've encountered a bug or because you have some frustration with an AstroPy feature that you use, there's plenty of room for inspiration and finding things to do in the issue tracker. So there's over 1,000 open issues with a pretty extensive tagging system, label system. So I feel like there's an issue for everybody in there if you're looking for something. And this is also an awesome thing for students or interns to also do. So if you're thinking about mentoring students or folks newer to coding or newer to astronomy, that could also be a really great place to start. I cannot overemphasize the wonderful community that we have on Slack. And so if you're not quite sure if an issue is stale or if something is harder or easier than you think it might be, pretty much all of our package maintainers are on Slack. And so you're absolutely welcome to discuss via the GitHub issues, but I also highly recommend Slack, where there are channels, specific channels for every sub-package. We also have extensive documentation for the code guidelines and for the development workflow. We also ask that pull requests have an update to the documentation, that they have tests, and that there's a change log entry, and that's discussed more in all of these guides. And again, there are a good forum for discussing how to implement all of these things is in the Slack channel. Usually there will be pull requests. Usually there will be, I don't want to say extensive, but discussions, because a lot of people care about AstroPy, and so we definitely need the contributors to not just submit pull requests, but to engage in those discussions and submit revisions. And so contributing may be require a little bit more patience and a little bit more back and forth than some of the development workflows that you're used to in your own organizations. So be emotionally prepared for that. So again, for the ADASS community especially, we really would love for y'all to join us. And so the AstroPy Slack is a developer focused. There's channels for each sub package, so you can pick and choose. It's not super noisy if you can hone in on which sub packages you're the most interested in. Anybody can join using this URL. If you're not on Slack, or for whatever reason you prefer a different channel, so we do have the AstroPy Dev Google group, which is where we announce major changes or have major discussions. Sometimes we'll point to a GitHub issue and say, hey, we're thinking about adopting NEP 29 and figuring, deciding our adoption schedule or modifying the release schedule or something like that. Those types of major changes and or discussions are brought up on AstroPy Dev. So I highly recommend joining that Google group just to stay in the loop. Yeah, I think I'll just keep going before I ask for more questions. So as I said earlier, in response to Azali's questions, the Astropy project now has funding. And so we got about $900,000 from the Moore Foundation over 3 years. It started back in October 2019. And as I'm sure most of y'all are aware, this is a really major change for the project. For our year one, or phase one, as we call it, we focused on funding for the existing core maintainers. So I call it keeping the lights on, everybody who's already doing a bunch of things to get support as contractors, summer salary, teaching release. We did not use any funds to support full-time. There are no full-time positions. So all of it is for people who are working on AstroPy part-time and to support that part-time effort. We've also made a lot of progress, and so we had a whole dedicated working group on formalizing our governance structure and charter, so that we can make decisions in a more documented way. And so that's also currently still under discussion, and we're calling it APE 0. So because it's our charter. So AstroPy Proposal for Enhancement 0, going back in time. And so that's currently pull request 61 in the AstroPy APES repo. Another change which we've implemented this year is working towards radical transparency. So the notes from the Interim Finance Committee now are a public Google Doc. The notes from the coordination every 2 weeks or every month coordinating meeting are now also available for view and comment. And the things which those committees are working on are also posted in the Astropy project repo as issues. So folks can see, what we're working on, what types of decisions we're making, and what's going on. And I'm very, very happy with that. It's definitely, at least so far, led to a lot of discussion, and we're happy to have more people taking a look and giving us not giving us, but contributing to the discussions and the decisions which are being made. Planned activities. So what we did in phase one was just phase people who were already doing things like and there was some stuff for that wasn't already being done, like new stuff, but for the most part, it was a lot of keeping the lights on. For phase 2, we want to focus more on funding community-led efforts. So for example, if someone said, I really want to push on spec reduce, that would be something which we'd be interested in funding in phase 2. We also want to apply for a NASA grant. So one of the goals of the more funding is to get our governance structure in a state where it is more appropriate and we can be more competitive for things like NASA grants. And so there is a new call, which I also want to call everyone's attention to. And so it's in NASA Rose's 2020 E7, it's called, and it's support for open tools, frameworks, and libraries. And it is specifically for maintenance of existing packages. It is not for new development. And so it's a new chapter in our world of funding available for software. And I'm really
3 minutes now. Sorry.
thank you. Yeah, so since I do want to have time for more questions, so the goal is to use the grant funding, the NASA funding as well, to support the community development model and not to uncover the entire cost of the project. So we're not planning on hiring full-time people. Our plan is to distribute the money, across the community to facilitate more community engagement in the project. So we still want you. So my summary slide, the Astro project is healthy. The code base is well maintained and growing. We're getting funding and we're thinking hard and being careful about how to spend that funding to help with sustainability and enabling growth. We have the Learn Astropy site, which is a potential future home or discovery portal for your project's educational resources. And we would love more contributors from the ADASS community. Thanks. And so I'll take the last 3 minutes for questions.
Anybody has a question? Nothing yet. Well, if not, I'll take the opportunity to ask one. A few years ago, I looked into contributing, and I found that it was very daunting having to read all the documentation needed in order to contribute, and that really put me off. Even though it's my job to write software. So has this been addressed? Because I know it was a known problem and there was some interest in fixing that.
Yeah, so the way it's being addressed in at least 2 ways at the moment. So one of the things that we did in phase 1 is that we hired a, what did we call, software operations support specialist. And so Madison Bray is now part-time to help with the contribution pipeline. And so we have a person who's tasked with seeing the pull requests, saying like, oh, maybe this isn't passing tests, or maybe you didn't add documentation, and offering help with that, or doing it like if it's something like there's something obscure, or you just need to add a change log entry, helping get those PRs across the finish line. So we have a person dedicated to making that easier. And to, I think something that's also on Madison's list is updating and the documentation. I think the documentation is important. We don't want to, we want to make it easier for folks to contribute without necessarily lowering our standards, which is a challenge. And so we want to provide more support for the contributors so that it's basically less work and easier. Another thing which I skipped over, right? And so one of our planned activities is to institute a contributor to maintainer mentoring program. And so that's also a place where we're hoping, if folks have maybe made 1 or 2 contributions, to provide them with more support to become a maintainer. And so it's also the more maintainers that we have, so the more people who are taking a leadership role in supporting a package or a sub package, I think the more support we'll have for folks to make contributions. So it's definitely something that we're aware of and we're still working on. It's a great question, Kathleen. Adrian, did you want to talk any more about the role of the SOS position in supporting contributors?
I think you summarized it well. But I think, yeah, the idea is to take a look at all of these questions, not just helping with pull requests and that, but also look at the pipeline of going from user to contributor to maintainer.
Okay, well, thank you very much, Kelle.